Okay, what are criterion referenced scoring procedures? I'm sure you've all experienced tests as students, and you will be getting some kind of an assessment from me. And these days, I'm busy doing I'm doing multiple choice tests, because we're trying to give students practice doing multiple choice, since they show up on the praxis, which you have to take when you do the ASHA, prepare to get ASHA certification. So, how do I score my multiple choice test? I use criterion reference scoring approach. And criterion reference scoring approach is an approach to scoring in which the performance of an individual is compared to a standard or criterion that the test creator establishes. What is the right or wrong answer, or what behavior are we looking for? And usually a score is applied to that response. So let's say and that's the score, that's the criterion score. That is criterion reference scoring. So for example, if on my multiple choice test, question number 1 says, what is content according to Bloom and Leahy? And A is ideas, and B is syntax, and C is phonology, and D is tap dancing, and E is watching a movie or something. The answer is A, and it's A because me, Dr. Moses, decided that that's the answer I'm looking for. I've made that decision. Or I say, how do you define language? I usually don't do multiple choice tests. I like to do short answer tests. So I might ask you for, what is the definition of language? And you may give me a definition that you learned at the undergraduate level and say that it's a symbol system for representing ideas. But the Bloom and Leahy definition is, language is a code whereby ideas about the world are represented through a conventional system of arbitrary signals. That's the Bloom and Leahy definition. I'm Moses. I decide that I want the Bloom and Leahy definition verbatim. You'll get 10 credits if you give me the full Bloom and Leahy definition, and 0 credits if you give me anything else. 10 credits. And I'm the boss. I'm the person who created the test. That's the score you get, because that's my criterion for defining language. And that's criterion referenced scoring. You're scored with reference to the criteria for an acceptable response set by the assessment designer, if you're following me. At the end, I probably collect multiple samples of your performance, add the scores up, and you get a total score. That's a typical test scoring approach. That's criterion referenced. Now, other examples of criterion reference scoring are the kinds of an assessment you do when you're doing write goals and assess whether or not a child has achieved the goals of treatment. And usually you write your goals to include a criterion. For example, and the criterion is a score of some sort, a number of some sort. For example, you might say a child with an articulation deficit who is working on backing, who has a process of fronting, is working on back sounds. You might say child will produce the k sound in the initial position of CBC words 8 out of 10 trials. 8 out of 10 trials. That's a criterion. And you are defining the performance that you, the clinician, who's the boss, who's the assessor, establishes. That is, producing the k sound in the initial position of words. That's the behavior. If the child does it, he's accomplished it. If the child doesn't produce it at the initial position, produces a t instead, for example, says tat instead of cat, you're not going to accept that. It's not going to get the score. That's not going to be a trial in which the child achieved that behavior. And the criterion 8 out of 10 then is the child is stimulated to produce the that k sound in initial position, maybe in 10 words. You present the kid a picture of a cat and a crow and a cab and whatever else. I'm just making this up off the top of my head. Nothing too important about the stimulus items here that I'm mentioning. But that's criterion reference scoring, because I've set the standard for the child to behave, and I've set in a criterion too for the, in this case, the numbers of correct responses that I'm looking for. Following me? That's criterion reference scoring. Even, you know what else is criterion reference, reflects criterion reference scoring? Scoring with reference to judgments with reference to a developmental taxonomy. The criteria, such as the Bloom-Leahy taxonomy. The criterion for performance doesn't have to be an arbitrary adult-driven criterion. For example, that language is a code whereby ideas, that particular definition of language, nor the k sound in the initial position, that particular behavior. Instead, it could also come from research on child development. It could be we could use a child referenced behavioral criterion. For example, we could say we want the child to code existence 5 times during a session. Code existence. Now, and that's, say we have a 5-year-old child who is minimally verbal. We're looking for the child to label any object and code existence using single words. Well, that's more of a child-oriented goal. That criterion is based on developmental research. But that's still a criterion, and the child gets credit for producing, for labeling objects 5 times. Doesn't get credit if the child doesn't say anything, or if the child says jump or something like that. That doesn't fall into the existence category. The existence category is names of things. So that's a criterion too, and that's a score with reference to a criterion. But it's a child, it's based on research in child development as opposed to more arbitrary criteria that you find on typical exams that are given in school. Any way you cut it, these are different examples of criterion reference scoring, because the scoring is the analysis of the information is against a criteria that the test creator, the assessment creator, establishes. Following me? And that's it. That's the end of scoring. You don't go beyond that. So the child is really compared to the child's performance is compared to the standard that the assessor creates, and that's it. Nothing further. The child's not compared to anybody else's performance, just to the criteria for performance that the assessor establishes. differs a bit from criterion reference scoring. Norm reference scoring starts out the same way that criterion reference scoring starts out. That is, the child is expected to behave in the child's behavior is compared to or assessed with reference to an acceptable target behavior that the evaluator establishes. For example, let me pick up the again, the protocol sheet for the PLS5, and here the child is, I don't have the stimulus sheet, but it's a page with multiple pictures on it, and the child's instructed to point to the ball, bird, shoe, balloon, and apple. The child gets a point if they do what they're told. They follow the instruction. That's the criteria that the test creator, the person who created the PLS, expected that. That's the behavior. If the child names the objects, if the child sits there and looks at the objects and looks at the page but doesn't give you any indication that they're focusing on a particular object, the child gets no credit. The child gets credit only if they do what the test creator defines as the criterion behavior. In this case, the child at 3 would have to identify all 5, would have to point to all 5 of these items to get the credit. They get 1 point. That's the criterion to get the point. And that point we call in norm reference assessment, I keep saying standard, which is the data collection procedure norm reference, but standard data collection does go together with typically with norm referenced assessment. So the standard data collection I'm doing usually is accompanied by norm reference scoring. And the very first step in norm reference scoring is the derivation of a raw score. And the raw score is the total number of points the individual gets on the assessment, and that is a criterion referenced score. The raw score is criterion referenced. It's the points assigned to the client, to the test taker, based upon that client's behavior with reference to some criterion that's established by the test. Most of these standard, by the way, norm reference tests have many, many items on them that the client has to react to, by the way. Like the PLS can have 20, 30, 40 items that the client would have to go through. We're going to be looking at these assessments when you do your PPTs, and as I speak to you as we move along this term. You'll see, like, there's a test called the phonologic awareness test, and that one has practically hundreds of items, literally, that a client who is actually responsive to the test has to go through. The praxis that you're going to take, that's a standard norm referenced assessment, and you have many, many items that you have to deal with on that assessment. LIU doesn't require the GRE, but if you took GREs in your life, or SATs, those, you know how many items you have to deal with on these assessments. Many. The first score you get is a raw score, which will be the total number of items that you correctly responded to according to the criteria established by the test creator. The difference between standard and, sorry, I keep saying standard, but I mean to say norm reference scoring, and criterion reference scoring, norm referenced and criterion. In that criterion reference scoring ends with the raw score. That's it. The kid, you don't do anything else. You just compare that raw score to what the total possible number of points the client could have gotten, or the total behaviors the client could have shown had they responded correctly. The difference between the Criterion reference scoring and standard scoring is that you go to a second step in standard scoring. I'm sorry, in norm reference scoring. I'll never be able to say that without saying standard. Norm reference scoring. Norm reference scoring. You go to a second step. And that second step is the derivation of a standard score. And that means you're going to take the client's raw score, that Criterion reference score, and compare it to the scores that the behaviors that that individual's peers demonstrated in context of the assessment that you have administered. And you derive a standard score. The derivation of a standard score is ultimately with reference to the normal curve. So I am going to spend a little time here now talking about how a standard score is derived and really what it represents. Okay? That's where we're headed. Scoring, I cannot start the word norm reference without automatically saying the word standard. But again, standard, the term standard has to do with the way that we collect data typically. And norm reference is the way we score it and analyze it. What we're doing really in analyzing the data is taking a step beyond Criterion reference scoring. We get a raw score, we calculate a raw score based on the individual's responses to the questions that are asked or items that are responded to. We get a raw score, but then what we do is translate that raw score again into a standard score, which will be a score that allows us to compare that client to their peers in terms of how their score compares to the range of scores that would be achieved by a group of, say, their peers. Let's say we're evaluating a 7-year-old. That child would be compared to other 7-year-olds. Or a third grader, that child would be compared to other third graders, you see. Then that is what standard scoring is about. Now, what I could do in this lecture or in my presentation to you is simply point out to you, I have in my hand an examiner's manual from the PLS-5. So once I get a raw score, that is, I calculate the points that the client gets for responding to the items correctly, to whatever items they do correctly. I add up the points. Then in these manuals, you see that there are scores. There are these charts of scores, and the scores are arranged, you see, in the PLS-5 by age. So if I'm, say, evaluating, say, a 3-year-old, well, a 3-year, 2-month-old, let's say 3 years, 2 months, I leaf through the manual to the page that is for 3 years, 2 months. In this case, it's between 3.0 and 3.5. That's the page. And I find the raw score. See, along this column here, there's a raw score. That is the Criterion reference score. So say my client received a 28. I am sorry. As you know from my other from my live broadcasts on Adobe Connect, I keep getting calls on my computer on this computer, which is not really my computer. This is this computer. I get the kids' phone FaceTime requests. So sorry that I'm being interrupted, but if I start again, I'll shoot myself here. So I'll continue on. So here we go. There's a raw score, and then I can just find a standard score that corresponds to the raw score. I could just teach you to do that. Just look at the manual and find the standard score that corresponds to the raw score, and you would have that score. You would see how the child compares to his peers or her peers, you see. And there are also other kinds of scores on that page. Percentile ranks, confidence intervals, etc. Now we have to consider what these scores are about. But I simply could teach you how to use one of these manuals. I think, however, you could probably figure out, without my saying very much, how to use one of these manuals. You go to the page that corresponds to the age or grade of your client. You find the score that is the raw score, that is the Criterion reference score that the individual will receive, and you find on the chart a standard score, percentile rank, and a confidence band, and that's what you do. But this is a university, and this is a university lecture here. So my job, I think, is to explain to you really how these scores are actually derived when these instruments are normed, that is created. And so you have a sense of what these scores are about, A, and B, you could make maybe some judgments with reference to this, your sense of what these scores are about. And in the future, you may want to do research or create your own assessment. It's a good way to make money in this field. Create a popular assessment instrument, particularly one that's accepted, becomes popular in a school system or in school systems. That is a sure way to make some good money. Somebody by the name of Don Hamill, who is the president of ProEd, which is the #1, I think it's the #1 publisher of assessment instruments in speech-language pathology related to learning disabilities, but I think across all the disorder areas. Started out as a speech-language pathologist himself and came up with the test that we know as the TOLD, the test of language development, and did quite well for himself. He's in the Fortune 500. So not a bad idea to create an assessment instrument if you have a good idea for one. Now this is going to be, I'm going to be talking about the way these standard scores are derived, and that relates partly to the way these assessments are normed. And I want to talk about the norming of these things too, along with the various kinds of scores these standard norm-referenced assessments yield and what they're really about. And this is a bit of a challenge because I'm going to be speaking to you and also trying to illustrate what I'm talking about with reference to actual written material, which you'll see on the PowerPoint slide, on the normal curve, and on a Word document that I'm going to try to integrate with this lecture here. So here I'm going to take a shot at this. The standard score, how is it originally derived? Where does it come from? How is it created? Well, when these tests are first created, they have to be standardized again. That's another use of the term standardized. And standardized means before you can give them to your client, before they can be used professionally as an assessment instrument, they have to be tried out to see if they do what they claim to be doing. So that certain statistical and analyses and research programs have to be carried out. Reliability and validity has to be established, and we will be discussing what the reliability and validity are and the different types of reliability and validity. That'll be our next topic. That's established. And these, again, these scores against which your client will be compared have to be established. The way they're established is this. The assessment, once it's created, is given to many individuals, and usually to assure, in these days, an absence of culture bias, the population to whom this assessment is given vary and is inclusive and includes individuals from different geographic areas, from different cultures, from different races, etc., so that there is a minimum of culture bias. We'll discuss that a little bit in a little while, this culture bias business. But that's what's done. And then what happens is these individuals take the assessment, scores are calculated, and what is generated is a normal curve. Now, what is a normal curve? Also called a bell curve, or a chance curve as well. That is a random curve, strangely enough. In any event, what is a normal curve? Let's take a look at one here on this slide, and we see that it has a hump in the middle, and it drops and smooths out at a low point on either side. I'll give you a definition for the normal curve. Usually in a live session I would ask you what do you think, or what have you learned in the past that the normal curve represents, because I know you've had that. This is nothing new to you, and I think everybody here has had a statistics course previously, I hope so anyway, and a research course. So you've had experience with this normal curve, but let's just remind ourselves what it is, and why the hump and everything, why the shape. My definition of it is the central tendency and range of scores of a particular population, a population's performance on a particular assessment. Again, it is the central tendency and range of scores of a particular population on a particular assessment. Now, why the hump in the middle? You see the hump in the middle? Why that? Well, that's the central tendency. And in any population, most people will score at or near the mean, near the center. By the way, the statistic that represents the central tendency, that is the average performance of a particular group of people, that is what the mean is, really, the average performance. The hump is that most individuals in a population will perform at or near the mean. That's the central tendency of any group. The range of performance is on either side. On the right side of the hump is the higher than average performance, range of performance of that group, and on the left side of the hump, the lower than average performance of the group. That is the range of performance. Now, what statistic is used? What statistic is used to calculate the range of performance? The statistics that's used to calculate the central tendency is the mean. That is the average, and we all know how an average is calculated. Add up all the scores, divide it by the number of people taking that assessment. That is the raw scores. You add up all the raw scores and divide by the number of people taking the assessment. That's the mean. What's the range? What statistic? Yes, if you've had this before, you know that statistic, well, there are a couple of statistics that can be used. The most typical statistic is what? The standard deviation. That's right, the standard SD, standard deviation. And ideal legislation, which is that legislation that qualifies children to who receive assessment to receive a free, appropriate public education in the least restrictive environment, that is, to receive intervention if a disability is identified. That legislation makes the classification of disability with reference to standard deviations. What is a standard deviation? What exactly is one of those things? Again, if you've had statistics and previous research courses, you have encountered the standard deviation. It's a descriptive statistic. And it's calculated with reference to the variance, which is also about range of performance among individuals in a group, the variance. What is the standard deviation? The definition that I give for standard deviation is the average difference from the average. The average difference from the average. So you know how an average is calculated. You add up all the scores of individuals, divide them by the number of individuals, and you get the mean. And the mean will be that middle point in the curve. But strangely enough, you get this kind of shape of performance when you test lots of people, when you assess lots of people on a particular kind of assessment. Particularly if the assessment is well designed, you get this curve. Or the assessment is a natural biologic assessment, such as the size of people's feet, for example. If you were looking at a group of, say, adult men, and you were opening a shoe store and wanted to know how to stock your store, you might do an analysis of foot size, so you could know what shoe size to stock. Well, if you say assess 20, 100 or 1,000, say 1,000 adult men, adults being 21 and over, and calculated the mean, and then looked at the range of scores, you would end up with a normal curve or a bell curve, because biologically that's the way this species is. That's the way behavior, or physiologic at least, characteristics are. There are average characteristics, and then there are higher and lower than average characteristics. There's a range of characteristics of any particular group. That's true biologically. That's also true on these assessments. When you give this assessment to several hundred children of a particular grade or age, you will find there will be an average and a range of performance. In fact, if there's not an average and range of performance, then you've done a lousy job designing your test, and you go back to the blackboard or to the drawing board, that's the term, drawing board, and redo the test, make some of the items more difficult, maybe make some of the items easier. So again, you give the group, when you give this assessment to, say, a large group of individuals from a particular population, say third graders or 5-year-olds or whatever, you will find that you have to find that there's an average and a range of scores, and when you chart them, they end up looking like that bell curve. That's required, actually, when you norm an assessment. That's, in fact, the process of norming an assessment is making sure that you do get this bell curve as performance quality pattern from any group of people you give that matched population who receives the assessment. So, how is the standard deviation calculated? I would like to look at that. Standard deviation is the average difference from the average. Now think about it. Once you calculate the average or the mean score in any group of people taking an assessment, once you calculate the mean, if you go back and look at the actual physical scores individuals get, or you give the test subsequently to other people, even though most individuals taking that assessment will cluster around the mean, and thus you get the hump in the curve. How many people actually get the exact average score? Say the average is 55 on a test that has 150 items on it. The average score is 55. It's 55. How many people would get exactly 55? Not a lot. Not a lot necessarily. Some people would get 56. Some people would get 57. Some people would get 52. Some people would go below the average, above the average. Most people would be around the average, a couple of points higher, a couple of points lower, but right dead on the average, not that many. Now, some people would do way better than the average. Some people you will have found did way worse than the average. So you would get a variance. You would get differences in performance in a group, any group of individuals who are taking the assessment, even if that group of individuals is matched on a particular quality, like grade level, third graders, age level, 8-year-olds. Whatever basis that you have for matching them, usually in these tests, tests are normed with reference to age or grade, because that's who clients are compared. Those are the groups clients are compared to, if you're following me. So then how is this the standard deviation calculated? Well, as I said, it's the average difference from the average. So I'm going to show you this, put this on, hopefully I'm speaking right now on top of a slide or Word document here. And you see what I've done is listed a set of, just for the heck of it, 5 different scores, just to illustrate what I want to say. 5 scores that 5 different, say, third graders received on a the self 5 assessment of the 5 to 8-year-old part of the assessment, or part of the assessment. Now we calculate the average of scores, but notice of the 5 scores, only one is exactly on the average. A couple are below the average, a couple are above. Now just say we won't, and let's do it. Let's find out what the difference is from the average, the difference. So what we do on the, you see what I did, is subtracted the actual score from the mean. I subtracted the actual score from the mean, because the mean is the average, and only one person hit the average. So we want to have a statistic that represents the average difference from the average. So what I do is subtract the real scores from the mean so that I get the difference score. And some different scores will be plus scores. People will have done better. Some of the different scores are minus scores. People did worse. See that? Then I get the differences. Of course, I want to keep all the differences in play here, because it's the average difference from the average. But I have plus differences and minus differences. Now, if I want to calculate an average and I add up the differences, the minuses are going to undo the pluses and I'm going to lose all my data. So I need to get rid of the minuses and pluses in calculating a standard deviation. There are 2 ways I could do that. I could erase the minuses and pluses, and that would do away with them. But you know statistics, they're always more complicated than they might need to be, or they take things into consideration that we mortals don't consider. So rather than take away the minuses and pluses, just erase them, there's another way to get rid of minuses and pluses, and that is square your numbers. If you square the numbers, square the differences, the minuses and pluses go away. And that's exactly what you do, and that's what the statistical package does when it calculates a standard deviation. You square each of the differences, then it adds the differences and finds the average difference from the average by dividing it by the number of individuals taking the test minus 1. and that's called the degree of freedom, -1. 1 is taken away statistically. And then you get an average. But remember, the average is squared now. The average difference will be still a squared number. Remember, we squared each number to get rid of the minuses. So to undo the square effect, we take the square root. And that's exactly how a standard deviation is calculated. It's the average, n-1 average, of the sum of the squares. That's actually the variance, and then the square root of that's the standard deviation, is the square root of the sum of the squares of the differences of scores from the mean. That is that average calculated as the divisor, I think that's what it's called, is n-1 on that. So you see we calculated a brief and quick standard deviation, SD. Now, once you have the average, then once you have a number, you add it once to the average, and you get 1 standard deviation above the mean. Add it twice to the average, 2 times the SD number, that's 2 standard deviations above the mean. 3 times the number, 3 standard deviations above the mean. If you want to go below the mean, you take the standard deviation number you calculated and subtract it once for 1 standard deviation below the mean, subtract it twice for 2 standard deviations below the mean, and subtract it 3 times for 3 standard deviations below the mean. Ideal legislation dictates that a child must perform more than 1 standard deviation below the mean to qualify for service, to be classified as disabled. Actually, if the child has only 1 disability, speech, say, and nothing else going on, the child actually needs to be 2 standard deviations below the mean, needs to perform 2 standard deviations below the mean. If there's another disability associated with speech, say a movement disability or a cognitive disability, then the kid qualifies for service at below 1, really 1.5 standard deviations down. The child will qualify for speech service. Now you can think about a few things interestingly about this. First of all, the nature of disability. It's really a construct. Disability is a construct. In this case, in the case of ideal legislation and how kids are these days qualified for services, it's based on legislation. So legislation dictates that 1.5 standard deviations down or more is considered a disability in terms of performance on these norm-referenced assessments, standard norm-referenced assessments. Next year, maybe a new law will pass, and they will say 2 standard deviations down or 2.5 standard deviations down, all with speech all by itself, or with another disability accompanying it. Then that would be a disability. On the other hand, but then something that's a disability now, 1.5 standard deviations down, will no longer be a disability. It's not, at least by law, it's not a disability anymore. Interestingly, disabilities are constructs. They are judgments that we make or calculations that we make. They're the outcomes of judgments or consequences. Or statistical calculations, that's what I meant. Statistical calculations, think about that. That's an interesting point, perhaps. Also, as we go through these norm-referenced, standard norm-referenced assessments, I'm going to make the point over and over again, these assessments are not developmental. Deriving a standard score is not a developmental analysis of a child. That is because the behavior that you're evaluating on these assessments are not natural behaviors. They're not behaviors that are spontaneous or analyzed according to organization, which I'll come back to shortly. They're rather responses to questions or stimulus items that individuals made up, a test creator made up, that are not necessarily natural, but really are intended to uncover learning issues, really. We want to talk about really how these standard norm reference assessments are designed. And they're typically designed against information processing constructs. We will think about that as we go along here. Right now I'm just talking about scoring, and that's an aside. These things are not developmental. And standard norm referenced assessment is not. Norm referenced assessment, norm reference scoring is not a developmental way to score. It is a comparative way to score on an instrument that is somewhat artificial, that is created to intentionally explore some aspects of a child's behavior, usually the behavior that's the kind of behavior that's demonstrated and employed in a school setting where the child is expected to use language to learn. But we'll come to that a little later again as we explore these different assessments. Right now I want you to think about what standard deviation is about. And remember, you will be using standard deviation to qualify children for service. You will be reporting that children are performing 1 standard deviation below the mean, 2 standard deviations below the mean, 1 standard deviation above the mean. You will be using standard deviation terminology in your diagnostic reports. That has a 5-child standard deviation calculation. Let me just add this to my comments to explain the numbers that you see under the normal curve there. You see that the average is 50. You see that the standard deviation is 2. So therefore a score of 52 by a child would be 1 standard deviation above the mean, 54 would be 2, 56 would be 3 above the mean. Below the mean, 48 would be 1 standard deviation down, 46 raw score would be 2 standard deviations down, 44 would be 3 standard deviations down. Given that this was real data, now you can't calculate on 5 kids, you need 500 kids to get, as you know, statistically you would have no validity with such a small group. I'm just using that as 5 scores to illustrate the calculation of a standard deviation. And then you would interestingly find that there are few outlier children, very few, but some who do very, very well, 2 standard deviations up, say. Very few kids, but some in any population who would do very poorly on these standard norm referenced assessments and be 2 standard deviations or below. But most kids, again, would cluster around the mean. The kids who receive service would be the outlier children on the low end of the curve. Okay? Now here's another normal curve slide here that has numbers on it. You see what proportion of the population, when you generate a normal curve, strangely enough you find that plus or minus 1 standard deviation accounts for 68% of the population who took that test. When a test is normed, 68% of the population upon whom the test is normed need to fall in and will fall into the plus or minus 1 standard deviation central tendency area. That's the majority. You will pick up another 13.5% of the population, and you'll go up to about you'll pick up 27% of the population totally, 13.5% above and 13.5% below the mean, going 2 standard deviations out. In other words, that will account for 96% of your population. You'll pick up another 2.5% and get to 5% totally, 2.5% above the mean, 2.53 standard deviations below the mean. And you'll pick up 99% when you go out to 3 standard deviations. There'll still be a few additional kids left who do even more poorly or better than 3 standard deviations below or above. But the terms that are applied, by the way, the kids we're interested in our field are the ones that perform below the mean. Below the mean. Again, more than 1.5 standard deviations below the mean. And what we want, we use the following terminology to describe the kids who perform below the mean. Another score is a confidence interval, confidence band, and that is a decision one makes. One could report a single score for a child, a single score, but just think of your own self. Just say on the praxis test that you take for the ASHA to be certified, to get ASHA certification. Usually the ASHA test requires that you perform 1 standard deviation above the mean, and the score they're looking for you to receive is a 600. And I'll talk about this business of substituting scores, these z-scores. They use 600. Say you get 599, how would you feel? You get 599, you don't pass. 600 would have passed. You know what the praxis test is about. It's a lot of questions. You missed 1. You would be very upset. Maybe it would be more fair if they took into consideration the reliability of the test. That is, if one took the test over and over again, what would be the range of scores an individual would receive? That's called the standard error of measurement. We'll mention that. We will talk about that when we discuss reliability. Just say that was taken into consideration. Then instead of saying that you got a 599, considering that if you gave took that test multiple times, you know that you've guessed on some items or you lost attention on other items, and therefore your score may not be may not really represent what you're ultimately capable of. It may not have been a dynamic assessment of your performance on the praxis. What might be fairer? Maybe it would be fairer then to report your score as a range and say that on any given day, at any time, you would have scored between, let's say, a 590 and a 610. That would be fairer, wouldn't you say? Then you would have, by the way, then passed the exam. If you fail the exam, well, you wouldn't feel that badly perhaps, because you may have feel badly, but you still may have done so poorly that it's not like it was a chance error that led you to fail, but rather preparation or something that perhaps you could address. So we couldn't, and all of these standard tests, standard norm reference tests, or most of them, allow you to report scores, either as an individual score or as a confidence band. And you could say, you could choose between a level of confidence, which is usually 90% or 95%. Think about this: the more confident, the wider the band or range of scores, the more confident you'll be. So a 95% confidence would be a wide range of scores that you would report for the client, a wider range of scores. A 90% band, you'd be a little less confident, but that would be a little narrower, meaning confident that if the person took the test over and over again several times, you captured where they will ultimately perform. So the confidence band reflects the width of that confidence band, the statistics behind it, reflect the reliability of the assessment instrument. That is the differences in scores one gets if it is administered multiple times. We'll get to reliability in a subsequent lecture. But you therefore, again, have in these assessments the potential or the option to report scores as a confidence interval. And the last score I'm going to mention is the percentile rank. Percentile rank I'm sure you're familiar with that. And that's a way of talking of reporting scores according to the ranking, that is the order. My son is here keeping an eye on me. He's about to go. We're about to run out to his clarinet lesson, and I have to come to closure on this, and so I can get him over there. Just to say that on percentile rank, you are reporting scores from the point of view of how many or what proportion of the population did poorer than the individual taking the test, or given the individual taking the test, at what level is he performing compared to all other individuals if you rank them in order of score from highest to lowest. 99% would be great. That's a great percentile, because that would mean that 99% of all people taking the test did more poorly. 1% did better. On the other hand, a percentile rank of 1 would not be so good. That meant 1% of people taking that test would have done more poorly than you or that child, and 99% would have done better. Average percent, again, a 50 in percentile rank more or less corresponds to the mean, but that is called percentile ranking. And all of the assessments provide you with a standard score and a percentile rank. I have one more thing to talk about next time we meet, and that will be the z-score, the way that standard deviation scores are reported, are represented, and they're represented by numbers other than the raw score. So we'll get to that next time.